Hello, welcome back. This is Roger Royce with the 10,000 Startups podcast. And today we are talking to David Kiewlich. He is the founder at Tomorrow Biotech Corporation. He is a serial entrepreneur in the biotech space and also the founder of Badass Labs, which we're going to talk about, where he helps founders navigate the journey from concept to commercialization in biotech and climate innovation. So, David, thanks for being here. We've got a lot to talk about because this is certainly an interesting topic. And, we're going to, I guess, take a little bit of a divergence from my usual podcast format. Normally, we focus very much on startup law, and we're going to get a little bit more into startup practice, what's going on in the environment, the next evolution, especially in biotech. Because I think this is really interesting and really exciting what you've managed to do. And I think you're really a trailblazer here, leading the way in what the future of incubators, co-works, or what you call startup catalysts are going to look like. So let's just start with that. Tell me a little bit about Badass Labs and Tomorrow Biotech.
Sure. Well, thank you so very much. And I really appreciate being here and I appreciate the opportunity to chat. And so the way I looked at it, I'm a serial founder. I've done six startups of my own in oncology, cell-based therapeutics, and synthetic biology. Multiple exits. I've been doing this for many years, but I felt it was just incredibly hard to get everything done that I wanted to do for my own startups and said, we have to make this easier on the founders because ultimately, this 2 to 5% success rate that we have historically sort of normalized is not going to make the world a better place. So we have to just make this easier. And that was sort of the foundation of why I wanted to start an incubator myself. But it was really about how do we bring this innovation to the marketplace? And that was where Badass Labs was born. The idea of we need to lean in more aggressively and more enthusiastically to help these founders who 80% of the time are first time founders. So they've never run a business before. And therefore, that inexperience really hinders their ability to execute and get the work done. So that was sort of the foundation about why we do this. So it's very, very high touch, sort of concierge style, where everything is individualized for each company.
I see. Okay. And you mentioned something really interesting, a pretty low success rate typically out of these. Is that all of them? Is that even the really successful ones?
Well, I mean, not everybody reports their numbers, so it's difficult to say specifically if this is standard for everybody. But if you look at Y Combinator, which is considered one of the best, they do report their numbers, and their success rate in the biotech side hovers in the 7-ish% range. So it's certainly better than the average, but it's not what you would call gangbusters wonderful. In our space, over 5 years, or sorry, 7 years now, we've had 55 companies come through the space, 50 of which have been commercially successful. So we're at 91%. And this is defined as the company has to have either an exit, such as an acquisition or outlicense, i.e., somebody wants to buy the company, or they are commercially successful, so they are making money and on their way either to profitability or are profitable. So that is ultimately what we classify as success within the space.
That is insane. To think that you're having that much success. So why is that? What do you attribute that to? Because I do startups, and the idea of 90% success is just sort of unknown in this space.
Totally understandable. I get that a lot, so no worries. Really, what it comes down to is historically, we've basically just told these founders, figure it out. And it's the old adage of it's hard to build the plane while you're trying to fly the plane. But if you add to it that you've never even seen a plane before, because this is your very first try, that makes it virtually impossible. And without guidance and support, it's not shocking that most founders struggle immensely, make a lot of rookie mistakes, they get overwhelmed really quickly. These are real problems that hinder execution. The other side is if you're expecting a founder or a small team to do dozens of different jobs, say, fundraising and the science and the waste handling and the acquisition and the IT and the HR and the brand building and the social media and the regulatory filings and procurement, and the list goes on and on and on. When you expect them to do all of those jobs, they don't do very well at any of them. That kind of code switching between those different tasks hinders their ability to focus on any given task, so they do everything poorly. This includes the science. Even if they're exceptionally good scientists, they simply don't have the time to focus to do it well. So that was the philosophy behind this, is we're going to take those low value, high risk tasks off of their responsibility so that one, these tasks are done by experts so that it's done correctly, it's done quickly, and it's done consistently. But it also frees up the founders to focus on the critical path, which moves their company forward more effectively, because ultimately they're going to hire people to do those jobs eventually anyway. So we just take that place initially, but we're also teaching the founders what goes into doing those jobs well. Because ultimately, when they go to hire people, if they don't know the job that they're trying to hire for, it's luck based if they're going to get a really competent person or team to do that job. That's not the way we should be running this. It should be much more intentional than that.
Got it. Well, let's kind of pause on the biotech side of this because that's what's sort of interesting. I mean, you are a biotech, a catalyst, and your background's in biotech, and I believe that you're technical as well. And all we ever hear about these days is AI, robotics, energy, everything around that. So what does that mean for biotech as a sector? How's it doing? Is it still fundable and financeable? Are there opportunities? Is it a space that somebody who's learning how to what a plane looks like should enter at this point?
This is a tricky question, because I think right now, I did a report just a couple of weeks ago for the first half, covering the first half of 2026. And there was about $2.5 billion of investment into early stage biotech. And
Mhm.
about $2.5 billion of that was AI in biotech. The rest of it was in the tens to hundreds of millions range. So it was like a tiny fraction of what was totally there. So there is massive, massive amounts of investment on the AI side right now. But this is going to create this incredibly complicated field where there's so many competitors that only some of them are going to figure it out. So it means that we're going to see, I think, a great purge of sort of the made it versus not made it, probably fairly soon, because there's going to be an expectation of profitability from this. And therefore, I think we will see a winnowing of that field rather severely. The challenge is that biology in particular is still not a very well understood field. And because it is a bit of a black box, like even how a cell works, it's really hard to simulate something you don't fully understand. And I think that is also creating a lot of challenges for AI and biotech as a prediction model. Now, as a data analysis model, I think it is very well aligned. And I think that's where we're going to see most of the successes, because the data that's being produced from some of these experiments now, some are approaching like a terabyte of data from one experiment. Human beings can't process that much data, but AI can. And it can find that pattern matching and identify things that human beings simply don't have the capacity to be able to sift through. So my guess is we're going to see a lot more involvement of that, as well as integrations of AI with automated labs, where the AI is trying to refine something that a human being starts a process, and then the AI goes through the reiteration processes to modify and enhance that and optimize it through an automated lab system that has either minimal or no human beings at all.
Yeah. I just have this feeling that we're about to enter this golden age of just pure science, fundamental research, because before it just wasn't, it just probably wasn't economical to do this, and there's been resistance by big companies and startups, of course, take that up, and now it's a lot easier for them. I'll give you an example. I had my genome sequenced recently, and I went through it with the scientist who did it the other day. It was dirt cheap, and he told me, he says, "Look," he says, "we found 3 million variants or mutations." Uh, we don't have time to go through 3 million pages, and no human does. He said, but the machine here has given us 12,400 that are kind of interesting and narrowed that down to four that tell you that of things you should pay attention to. And that's incredible, right? Isn't that? And that just tells me that now there's just got to be a lot more appetite to just digging in deep into this hard science. Am I reading that right?
Yeah, I love it. And congratulations on going through that. Hopefully it wasn't too scary, because some of the analyses can be a little bit confusing to be sure. But I personally believe that when personalized medicine was originally sort of brought to fore, which was in the late 90s and early 2000s, um, it had this promise of being able to align medicine with the individual. Now, unfortunately, it was sort of suggested that we would create individual drugs for individual people, and that was just never going to happen because there's no economics in that. And I think, unfortunately, because that was what was being promoted, or at least misunderstood as that's what was being promoted, that really hindered the adoption of this plan. What I think personalized medicine is going to do, to your point, being able to sequence people's genomes and identify this, I want to see it basically create clades of people where a given therapeutic falls into one of three categories. It's going to help you, it's going to do nothing, it's going to hurt you. If we could just do that simple division of people into those three buckets, it would save a huge amount of healthcare dollars because we wouldn't be prescribing medicines to people where we knew it wasn't going to help them or it was actually going to actively hurt them. That way, you would be far more optimal in how you deliver healthcare because that would be focused specifically on the people that would actually benefit from that healthcare. This could also be really useful for clinical trials because by identifying the people that are most likely to be beneficially impacted by a given therapeutic, that would make the trial smaller, but it would also make it much faster because you would see that impact more quickly because you wouldn't have all of this confounding data of where it doesn't help people at all. And so you would be able to identify therapies and get them through clinical trials much more quickly, which would ultimately be at far lower cost. So I have a feeling that once we get into this place, it's going to be really beneficial. The challenge, of course, is the regulatory framework of what happens with that data is still not completely worked out. And, for example, who owns it and who can make decisions off of it? Right? For example, if your employer knew that you had a gene that made you more likely to have a heart attack, would they want to employ you? And how do we stop that? Right? That becomes very tricky because I don't think we've worked out now that we have access to all of this data, we have to figure out how do we control it so that it's not used against people because they were born with a gene that they had no control over.
Yeah, that's really interesting. So kind of pivoting onto that, what is the regulatory environment like? When I think of biotech, I always just think of this, this massive moat, this regulatory hurdle that every company has to get past. And in fact, we never even expect startup companies to ever get profitable before they exit because it's just too hard to get. They might not even get their drug into the market. That's kind of my perception. I'm not saying that's actual practice. I'm just saying that's how we sort of look at it. Tell me, what is the regulatory environment like right now, and how do you see the future?
Sure. Well, I will first off agree with you that the vast majority of exits, at least from the therapy side, the therapeutic side of biotech, are absolutely not going to be profitable, right? You're probably going to exit somewhere during a clinical trial, not afterwards, which means this hasn't hit the market, so there's no generation of revenue. There are other aspects of biotech like ag tech, diagnostics, um, clean energy generation, things of that nature, where there is a profitability because you can have a commodity that you can sell independently. It all depends on how you define biotech. I define it as making a living thing do something for us. Okay. Um, Now, on the regulatory filing, yeah, on the therapeutic side, it is incredibly complicated, and it has been made a little bit more difficult recently with the fairly substantial changes at the FDA. And therefore, this has created a lot of confusion and a lot of resistance, which is problematic because we want to get this stuff done more quickly. And my concern is that other countries aren't having this kind of challenge, which means that they may be able to go faster than us. And, the FDA historically has always been the gold standard for the entire world. And many other countries use FDA approval as an acceptable thing for them. So to lose that leadership would be, I think, one, a little embarrassing, but two, I think would really hinder the innovation that we want to see, not just in the US, but potentially across the entire world. So I'm hopeful that we can get this kind of cleaned up. I believe that there's a lot of very interesting proposals that could be very powerful, but how long it's going to take to actually make sure that these proposals, for example, using AI prediction models to do toxicity studies instead of animal studies. This is a very interesting idea that could make this go really fast, but are those models really ready to do this consistently enough that we have high confidence that they aren't hallucinating? Because ultimately that could really impact human lives in a way that we don't want to see.
Mhm.
So there are some real interesting hurdles that have to be overcome. If we do that, I think it'd be amazing. But the question is if we do it. And
Mhm.
that is where we have to work really hard to make sure this works really well.
What would you say the regulatory environment is like now as opposed to, oh, say 2 or 3 years ago? Because again, I only know what I read in the papers, I guess, on some of this stuff. And I know we had a new FDA commissioner who has now left, Marty McCary, and I was following his Twitter, and he was saying that they were approving drugs, especially cancer drugs, way more quickly than ever before. And I guess that's a good thing, getting them into the market. And we all seen the recent press about all the things that are going on in U.S. health policy. Would you say it's easier now for a company to get into this space than it was 2, 3 years ago? And look what happened with laboratory developed tests, right?
Mhm.
We beat back those restrictions. Or is it still just so difficult that maybe you got to move to a different country if you're going to do this?
I think there's actually sort of two parts to that question. And one is direct, which is the regulatory environment. I think in many ways, we're trying to make this better and faster and more efficient. And I think that is extremely valuable. I hope the pendulum doesn't swing too far, that we get a little bit, shall we say, overenthusiastic and approve things when they're not quite ready. A terrible, terrible example of that is OxyContin and how quickly that approval went by, and we can see the ramifications of that. So I'm hopeful that we don't make that kind of a mistake. But it is great to see that we are moving at a much more rapid pace. I think the other half of that is getting into this field requires funding. And that continues to be very difficult to come by. And so I would say, from a regulatory point of view, yes, it is very much more attractive now. But I think from a funding point of view, it is still extremely hard. And I
Mm.
think, those are tied together getting into the field.
Yeah.
Other countries, particularly China, have really taken a much more enthusiastic desire to support this industry than the US has. And I think that is going to be a critical feature in who ends up being the leader in this field in the next, let's call it 3 to 5 years.
Yeah, you raise a really interesting point there. Not to get too controversial, but the Financial Times reported, oh, maybe a couple years ago, that big pharma was basically outsourcing all of their drug development, well, not all of it, but most of their drug development to China now,
Mhm.
because China is so big and they move so quickly and they iterate so quickly. But I've heard the flip side of that argument too, is that the quality may not be where we would like it to be. Are you able to express an opinion on that, being a person that's on the ground, in the space?
Sure. So short answer is yes, China is going very rapidly. They've built out extensive capabilities. For example, they already have fully functional zero human automated labs. We are far behind that in a just a setting. Um, China does have some really exciting assets that have come out. Absolutely. The challenge is one, what will happen if China dominates this field? Will they continue to behave the same way? I don't know. They could change their behavior once they control it. This is difficult for me to decide what will happen. The other side is that we shouldn't be giving up innovation in the US just because it can be done in China. We have different philosophies in how we do this kind of work and how we view innovation. And I think that there is still incredible value in sort of that, we'll call it the US not even knowing where the envelope is to break, right? It's like so outside the box. And that is historically what the US has been strongest at, is doing things first. We don't necessarily do them best, and we oftentimes will hand it off to another country to optimize it. Think the transistor, right? We built the transistor first in the US, but it was the Japanese and the South Koreans that turned it into something magic, right? That we as a country weren't really interested in optimizing it that way, but the rest of the world was. And we've seen that kind of behavior over and over again. And I think biotech falls in that exact same category, that we have historically really pushed the envelope to do crazy things, but then other countries have really made it awesome. And I think that is not something we should give up.
Mhm. Okay. All right. Well, with that, I want, oh, one last thing before we
Please.
leave. It's not only biotech, you're also doing some work in climate and ag tech. Can you speak a little bit with that market? Well, I do a lot in ag tech, and I know the investment market, it's just very down in
Mhm.
ag tech. I mean, AI is sucking all the oxygen out of the room, it sounds like. But climate and energy is still seems to be, especially energy, seems to be a hot space. And climate will always be something we're concerned about. Any comments you can offer on that sector?
Sure. Really quickly, we want data centers. We need these data centers to run this AI. And basically AI has shown basically an inexhaustible hunger for more power and probably more water. Both of these are not scalable in the same way that an AI is scalable, right? You can build lots of data centers, but you can't build power plants and find new sources of water to be able to keep that scaling going. So work on those two features, i.e. additional, mostly renewable energy because there's only so much fossil fuel on the planet. So that's just not going to scale over time. We have a bunch of nuclear here, so we actually have a fourth generation nuclear reactor company in our space. I think those are going to be aspects on the energy side that are going to be really much more effective. For example, there's a group that's looking at creating a wind generator, but not as a terrestrial, windmill. They're actually creating it almost like a blimp so that it goes up into the higher atmosphere because when you go high enough up, the wind never stops, right? If you get up into the jet stream, it's basically blowing at 200 miles an hour constantly and it never slows down. So that intermittent problem that wind has historically had goes away. So you can create base power capacity if you just get high enough up. Geothermal is the same way, right? It's basically a permanent, inexhaustible supply of power. We need to utilize these things much more consistently to be able to feed AI. But quite honestly, the world needs as much power as we can generate, right? Because we'll find uses for it. Um, And then on the climate side, again, if we can find ways to generate more energy, then that unlocks a lot of other aspects that can be utilized to make climate better. Because now power in and of itself is no longer the limiting resource value of how much something costs. If you can get that out of the equation, it enables lots of other things. And then with ag tech, absolutely. We've actually seen a huge explosion of ag tech because we're watching yields really decline worldwide. We're seeing huge problems with pests invading areas that it never used to be. And we're going to have to start addressing these very, very soon because ag tech does not move that fast, right? And ultimately, we need to be able to get this done more quickly so that we can keep crop yields high in hotter, drier environments, how we can manage pests that are now capable of going to areas that they couldn't before. All of this climate change has enabled things that historically have never been a problem, but they are now, and we have to deal with it now because we can't watch this all collapse. I mean, the simplest example is, grape growing in the Mediterranean has largely failed because it is just simply too hot. So where is the majority of the grape growing in Europe? It's now in wet, dreary England because the climate now has warmed enough for England to be able to support effective growing of wine grapes. But the
Yeah.
Mediterranean has largely failed because they're now at, 100+ degree temperatures constantly, and they just cannot withstand that. So it's interesting how we've seen this adjustment. We've seen it with coffee, we've seen it with chocolate. All of these areas are becoming harder and harder to produce. So we've got to figure out how to solve that.
Yeah, and that's true in the United States as well. Back in my home state of North Dakota, they're now growing corn. It's become a pretty big crop. When I lived there, it was just too cold. I mean, it wasn't, you didn't grow. I was surprised when I went back and I saw cornfields. I mean, I'm not saying none. I mean, there were some of them there, I remember, but way up in the northern part of the state where it gets super cold, or it has historically, because the climate's changed, the crop composition has changed. So we're seeing that around the world. Anyway, I digress.
No,
That was really
we could
interesting.
opine on this for days. I know
Yeah.
these are huge topics, but I really appreciate being able to chat with you about them. So thank you so much.
Oh, no, thank you, David, for being here. This is Roger Royce with the 10,000 Startups podcast. We've been talking with David Kiewlich from Badass Labs and Tomorrow Biotech on the future of biotech, the current state of biotech, and what he's doing with his startup catalyst. So thanks again, David, for being here. Roger Royce, we'll see you all next time.